Okay, Math 9, here we go. Let's get after it. We're almost through our algebra section. So we're getting into now inequalities. Now, don't freak out because nothing changes except for one minor detail. But first, let's look at what is an inequality. An inequality is similar to an equal statement, okay? But I want you to consider a number line. If we said x equals 4, what does that mean on a number line? Well, that means x exists right there and only there. Right? It equals 4. Now here, if we say this, remember this means x is strictly greater than, right? It's opening up to the x. So it means x is greater than 4. What that means is it's a hollow circle because x doesn't equal 4. But it represents everything bigger than 4. So it'd be an arrow going in that direction. It's a range of possible answers. You got to just imagine plugging in values for x. Anything that's bigger than 4 satisfies that statement. 6, 9, 52. They're all bigger than 4. So there's a whole range of possibilities. If you look at this one means strictly less than, which means since the x is on the smaller end of the inequality, it means it almost exists at 4, but exists as a range of answers that way. Anything in that direction will work. And then the subtle detail here is, well, now it's also equal to. So the only difference is the hole is now filled in because it can equal 4, but then also everything bigger, and it can equal 4, but also everything smaller. So that's a subtle difference between your inequalities. But the algebra of inequalities, except for one minor piece, stays the same. So let's look at some of that. So t plus 7 is greater than 4. So we're looking at this one right here, right? What that means is, well, I'm going to subtract 7 from both sides. It means t is greater than -3, which means, and I've made my own number lines here, they're not pre-numbered, so we can just throw a number on there just to make it a bit easier. Let's say -3 exists right there, right? It means that strictly greater than, hollow line, that way, right? That graphically would satisfy all possible solutions for t, but the algebra didn't change. Now if you look at the next one, I'm going to multiply both sides by 4. So r is less than or equal to 28. So again, I'm just going to say, okay, there's 28 on my number line. I can exist there because it's equal to, less than or equal to, but then a range of answers that way. So you have a range of possible solutions. Okay, so here's a two-stepper. I'm going to add 5 to both sides. And now I have 3t is greater than or equal to 9, and then divide by 3, divide by 3. See, none of the rules change. T is greater than or equal to 3. So again, here's my own number line. There's 3. I can equal 3, but I'm also greater. So there. So now I've been saying a couple times, there's a minor thing, and this is it. You can see here, I'm telling you to watch out, right? Because I have -3m. Now I'm going to try to explain that to you up here if you considered an equal statement, right? And the thing is with equals, it doesn't matter what's on what side because it's equal, right? So if you added 3m to this side and you added 3m to this side, you would then have the 3m on the other side, and you'd have 3m plus 12, and you'd have 0 over here. And then you subtract 12 and subtract 12. And if you look closely, what you've done right way over here on the left is you now have -12 equals +3m. You've changed the sign of the two things, but they're on opposite sides of the equal sign. Now, if it's an equal sign, it doesn't matter because both sides are equal, but as an inequality, it makes a huge difference. So if you're got to think about if you moved that 3m. So if I added 3m here and added 3m here, my m value is now on the other side of the inequality. So rather than always have to add, there's a simple rule to remember. I'm going to divide here by -3 and then divide here by -3. If at any point you multiply or divide by a negative number, this has to flip, okay? Because you divided by a negative, okay? So m is now less than or equal to -4. So you have to flip your inequality. So let's look at one more. Now, we're going to get rid of all of our fractions. So lowest common denominator. Lowest common denominator is 12. So multiply by 12, multiply by 12, multiply by 12. And you're going to get negative 3r minus 8 greater than or equal to 2. Remember, because 12 divided by 4 is 3, 12 divided by 3 is 4, 12 divided by 6 is 2, then you do your multiplication. And then you would add 8 to both sides, and you get negative 3r is greater than or equal to 10. But now again, you see, you have to divide by a negative. So the second that happens, you flip the inequality sign. So 10 over 3 is about 3 1/3, so let's ballpark this. Here's negative 3 and here's negative 4, so we'd be kind of here, and we're less and equal. So looks like that, right? But the important thing there is you remember to flip your inequality. That's the only additional piece for inequalities. Otherwise, all the logic stays exactly the same. Okay, we got one more to go, and it's a short video on word problems.